So hello everyone. So today we are going to solve the CSES problem, uh, coin combination setting. So let's have a read. Consider a money system consisting of n coins. Each coin has a positive integer. Your positive integer value. Your task is to calculate the number of distinct ordered ways you can produce some money sum x by using the available coins. Okay. So you have the money. You have to construct the sum x, and you have the coins C1, C2, C3, C4 up to Cn. Right. So in how many number of distinct ordered ways you can construct the sum x? This is what you going to answer. Right. Now for example, if you have the coins, you have three coins, 2, 3, 5, and you have to construct nine. So in how many number of ways you can construct nine? You can take 2, 2, and 5. You can take 2 and 2 times 2 and then 5 and then 5 and then 3, right? And then 3. And you are going to take 3 times 3 also, right? So these are the possible ways that you can from which you can construct the sum of nine. But one thing you have to note that we are going to construct the distinct order ways, right? We are going to construct a distinct order ways. What do you mean by this? The rearrangement doesn't matter, and we don't count as a different way, right? For example, 5 to 2 is a different arrangement of this, so we do not consider it as a different case that we do previously in coin combination one. Okay, so this is the question. So let's try to get the intuition how we can solve that, how we are going to solve that. So you have to note two things here. The first thing that if you have to construct sum and you have the coins, then you have two choices. You have two choices that you could take. You could take you pick or you not pick, right? You pick or not pick that one, that coin. If you are going to pick it, then next sum you are going to construct is sum minus coin. If you are not picked, next sum that you are going to construct is f of sum, right? Correct, simple. That you have to suppose you have to construct the 5. If you are taking the coin of value 3, then next the next problem that you are required to solve is f of 2, right? If you have to construct 5, you pick the coin 3, so you are looking for f2, right? That is 5 minus 3, sum minus coin, right? So this is the first case that you can pick or you can not pick. Second thing is we have to maintain the order, right? That distinct order, right? For this, we can introduce a condition that Ci is less than Ci plus 1. What is that condition? That if you are using the next coin, if you are going to use the next coin, it has to be greater than the previous coin that you are using, right? In that case, if you are using 2 to 5, then 5 to 2 is not considered as a different way. Why? Because this coin is lesser than, right? Next coin is going to be lesser. The 5 is lesser, 5 is greater than the coin that you are using in future. So this is not the case that you are going to be considered. So this condition ensures that you are going to make a distinct order list, right? By using these two conditions, let's try to fill our DP table. So by using these two conditions, let's try to fill our DP table. So what's the condition that we introduced? That is uh, these two scenarios. That is first is if we have to construct f of sum, then we can pick or not pick. If we are pick, then we have to construct for sum minus coin that we pick. And if we are not picked, then we have to construct for f of sum, right? These are the two cases that we are going to consider. And second thing, we have to maintain that Ci is less than Ci plus 1, right? So how we are going to fill our DP table? We are going to fill our DP table. So these are the sum that we're taking from 0 to 9. And these are the coins that we are going to take, 2, 3, and 5, right? So first of all, let's introduce the base case. What is the base case? Base case is if you have to construct the sum of 0. DP table represents the DP of uh, it represents the DP of coin, or I can say the DP of index. DP of coin index that we are using and the sum. If you are going to use, if you have to construct the sum of 0, right? So for all coins, it has to be 1. For all i's, it has to be 1. So we are going to fill this with 1, this with 1, and this with 1, right? So this is our base case that we are introduced. That is DP of I0 equals to 1 for all the coins that we are having, right? DP of I0 equals to 1. That is our base case, right? That is our base case. Now we have two scenarios. So how can we fill? In what fashion we are going to fill our DP table? We have to, that is so that this condition is maintained. What condition? This condition, right? So we are going to take the last index coin very first, and we are going to fill we are going to fill it firstly, and we are having the next row, right? Next row to fill this. So that is the reason that we are using the extra row, that is n plus 1, right? So let's try to fill it, right? What you have to construct the sum for sum 1, for sum 2, 3, 4, 5, 6, 7, 8, 9. If you are not pick, the transition would be dp of I plus 1 and the sum that you are going to construct, right? If you are not, if you are not going to take that coin, then you have to jump for the next coin, right? So for this, you have to look for the next row, and all the values are 0. All the values are 0. So for this, for all the sum, the not pick value is going to be 0 for all the sum. And for pick, you have to look for the, you have to look for the, yes, for pick, what transition you can make? Yes, for not pick, you can skip. For skip, you are go to the next index coin and the sum would remain same, right? And for the pick case, you are you are take the coin, and next you are going to construct for that coin that you are going to pick, right? So for not, for pick case, right, let me write it in a separate, write it separately, right? For not pick, the transition that you're going to make is dp of I plus 1 and the sum, and for pick, the transition that you're going to make is dp of I and the sum minus that coin that you're going to use, right? One thing you have to, uh, initially the pick equals to 0, and you have to introduce a condition. You are pick the coin if the coin of I is less than equal to sum, right? If you are going to construct coin, if you're going to construct sum of 1, this is sum, and you have the coin 5, you have the coin 5, yes, you are filled this. So for index 2, the coin is 5, right? You have the 2, 3, 5. For index 2, the coin is 5. So the coin value is greater, so we are not going to take it. We are not going to pick, we pick if the coin value is lesser than or equal to sum. So for this, the pick value is 0, 0, 0, 0, 0, because in all these cases the sum is lesser than, sum is lesser than the coin. Now for this, for 5, for 5 the pick value is 1. Why? Because you are going to pick coin of index 2, and next you are going to construct is sum minus a coin, that is 5 minus 5. So right, sum is 5 and the coin that you are going to pick is 5. The coin is 5, right? The coin is 5 at index 2, and the sum is 5, so 5 minus 5 is 0. So transition, the sum minus coin of I, that is 5, so dp of I is 2, so 2 5 2 0 that you are looking for. So the 2 0 2 0 is 1. So for this, you are going to make it 1, right? For this, you are going to make it 1. Now for the, for pick, now if you are going to take 5, if you are going to take 5, if you are going to take 5, you are going to look for next sum, that is 1, that is 2, that is 3, that is 4. And for all the 1, 2, or 3, 4, 4, all the values are 0. So dp of 2, 1, dp of 2, 2, 2, 3, 2, 4 is going to be 0. So we'll make it all as it is, that is 0, right? That is already 0. So these are the transition we can make for coin 2, right? For coin 2, right? This is 0, 0, this is 0, right? Now let's do the transition for the coin 2. Let's do the transition for the coin 2. Now you have the coin, you have the coin 2, and you have, and the sum that you are going to construct is 1, 2, 3, 4, 5, 6, 7, 8, 9. And you have the coin 2, and you have to find for not pick, you have to find for pick, right? For pick, for not pick, you are, what you are going to look for? You are going to look for next row, right? Next row, that is this, 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 and this. So you found that only one value is 1. that is at the sum 5, right? So for this, not pick value is going to be for 0, but for 5 the value is going to be 1, and for all others it is 0, right? Now you have to find for pick. If you are picking until what you are not going to, you are this condition is not satisfied. That is 2. You have the coin 3. Sorry, you have the coin 3. You have the coin 3. So until that you are not going to take. So this is going to be 0, right? Now for 3, the pick value is going to be 1, right? Pick value is going to be 1. Why? You going to pick of index 1, that is 3, and the next you are going to construct is 3 minus 3. So dp of 1 0 is going to be 1. So pick value is going to be 1. For all other cases you have to look for 4 minus 3, 5 minus 3, 3, 6 minus 3, 3, 3, 3. This is going to be 1. 5 minus 3 is going to be 2, 2, 4, 5, and 6. 1, 2, 2, 4, 4, 5 minus 3, 6 minus 3 is 3. Yes, 1, 2, 3, 4, 5, 6. Now 1, you have to look for 1. Sorry, this is not the case. Yes, 1, 2, 3, 4, 5, and 6. Right? You have to look for this. Now you notice that for dp of index is 1, dp of index is 1, uh, dp of 1, and let me write it. Index is 1, and the sum you are going to construct is 1. Right? If the sum is 1, if you are going to pick 3, next you are going to construct for 1. So if you are pick the coin of index 1, then next you are going to construct for 1, and dp of 1 1 is 0. dp of 1 1 is 0. And for dp of 1 2 is also 0. dp of 3 1 is also 0. dp of 4 is also going to be 0. Right? dp of 4 is also going to be 0. But for 5 it is going to be 0. Right? Uh, Let me write it for dp of, yes, dp of 3 is going to be 1. Yes. Now for 5, next you are going to look for 0, and node pick value is going to be 1. Right? Pick value is going to be 0, and the sum of node pick and pick is going to be 1. Here is 1. So dp of 3 1 dp of 3 1 is going to be 1. dp of 5 1 is also going to be 1. So that is how you can build your dp table. That is going to be 1. Right? For all other cases, for 3, yes, is at this case. The pick value is going to be, not pick value is going to be 0, but the pick value is going to be 1. Right? If you have to construct some 3 and you pick the coin 3, next you are going to construct for 3. So what you are looking for? dp of 1 3, and dp of 1 3 is 1. So for this the answer is going to be 1. Now for the 7, next you are going to construct, so 0 1, the answer is going to be 0. Now not pick value is going to be 0, right? But the pick value, if you are going to take 3, next you are looking for the 5. For 5 the answer is 1. So for this the answer is also constructed. Next you are going to looking for 3. For 3 the answer is 1. Pick value is 1, not pick value is 0. So 0 plus 1 is 1. You have to add. You have to add pick plus not pick. These are the number of ways for the current state. Right? Now let's try to fill this state. This for the coin 2. Let's try to fill. Right? Now for this the not pick value is going to be 0. We are looking for the next row. Not pick value is going to be 0. And the pick value is also going to be 0, because the sum is lesser than the coin. So for this the answer is 0. Now not pick value is going to be 0, but the pick value is going to be 1, because 2 minus 2 equals to 1. Right? If you are going to pick, next sum that you are going to construct is 1. Right? Sorry, 0 0. So for this the value is going to be 1. So the pick value is going to be 1. So 1 plus 1 is 1. So you have to update it with 1. Now in this case the next value is going to be, if you are not pick the value for not pick, the value is going to be 1, and you have to look for 3 minus, 2, that is 1. Now for this the value is 1. So pick plus not pick is equals to my 1. It is equals to my 0 plus 0. That is going to be 1 plus 0, 1 plus 0, and this is equals to 1. So for this, the answer is going to be 1. Right? Now, let's look for the 4. Next value is not pick value is going to be 0. If you are going to take 2, next you have to construct for 2, and 2 value is going to be 1. So you have to, for this, the answer is going to be 1. Right? Now, for this, the value is going to be 1. Not pick value is going to be 1. If you are going to take 2, next you have to looking for the 3. So for the answer is 3, 1 plus 1 is 2. Here you have to fill with 2. Right? Here the next is 1. If you are taking 2, you are looking for the 4. For 4, the number of ways are 1. And then you have to update it with 2. Right? For this, not pick value is going to be 0. 7 minus 2 is going to be 5. For 5, the answer is 2. So for 7, the answer is going to be 2. The not pick value is going to be 1. If you are going to take 2, you are looking for the 6. For 6, the answer is 2. So 2 plus 1 is 3. For 9, the not pick value is going to be 9. If you are going to pick 2, next you are looking for the 7. For 7, the answer is 2. So 2 plus 1 is 3. So for 9, the answer is 3. So this is how you can fill your DP table, right? These are the states that you're going to change. And DP of I and that sum is equals to me not pick plus pick, right? And the answer is going to be a DP of 0 and the sum that you're going to construct, right? Why we move upward fashion? Because we have to maintain the order, right? Because we have to maintain the order, right? So this is the uh, transition states and the intuition that through which you can solve the question, right? You have to, right? So let's see the code for this, right? Let's see the code. Let's take the input and next, and we have to define the coins vector, coins n. Now for int I equals to 0, I less than n, I plus plus c in coins of I, right? Uh, Next we have to define the dp vector, vector of int dp of n plus 1 comma vector of int x plus 1 comma 0. Now for we have to initialize it. Let's define the base case. Is for int I equals to 0, I less than n, I plus plus dp of I 0 equals to 1. Okay. Now for int I equals to 0, I less than n, I plus plus, what we have to do is we have to traverse for all the coin and we have to construct the sum from 1 to x, right? And for not pick, the transition would be dp of I plus 1 and the sum, and we initialize our pick equals to 0, pick equals to 0, and we definitely pick if the coins of I is less than equal to sum, and pick the transition would be dp of I and the sum minus coins of I. Okay. So finally we update our dp state with pick plus not pick. Okay, so this is the transition. Now see out dp of 0, x and l. This is the transitions and this is the answer, right? So let's try. We have the number of coins 3, we have to construct 9, 2, 3, 5 is the answer. So let's try to run it. Why it takes so much time? So we have to ensure that we move in upward fashion, right? We move in upward fashion, right? This is the important. Yes, so the number of ways is going to be 3. Okay, let's discuss the time complexity. The time complexity would be big of O n into x, right? First loop go from n minus 1 to 0, that is 0, that is going to be a n, and from the second loop is going from 1 to x. So the time complexity is going to be big of O n into x. Okay, and the space complete we use a 2D vector space of n plus 1 into x plus 1, right? So I hope you got this, right? Thank you.